All right, welcome back to the deep dive. Today, we're going to get into something that is like essential, really fundamental to aviation. We're talking about aircraft weight and balance.
Yeah.
Now, you might be thinking, well, I'm not a pilot. Why should I care? But, even if you're not flying the plane yourself, understanding how a plane is loaded
Yeah.
really unlocks the physics of flight and, crucially, aviation safety.
Right.
We're diving deep today. We've got excerpts from the Weight and Balance Handbook, and trust me, this is not just some boring regulations.
No.
It is like the heart of every safe flight.
Absolutely.
Yeah.
Yeah, this handbook, what it does is it lays out this incredibly meticulous process that pilots go through to make sure their aircraft are operating safely
Right.
within these limits before they even think about taxiing.
Yeah.
And it's detailed,
Yeah.
but it's non-negotiable
It's non-negotiable
when it comes to safety.
Okay. So our mission today is to pull out the core concepts, the methods from this handbook,
Right.
so you, the listener, get a really solid grasp of weight and balance without getting bogged down in all the technical jargon.
Sure.
Okay. So let's break this down. The basic idea, it's really twofold.
Yeah.
You got to make sure the aircraft isn't carrying too much weight overall,
Right.
and that the weight it is carrying is distributed correctly.
Yeah. Absolutely.
The handbook, it emphasizes this, allows pilots to figure out like the loaded weight and whether the center of gravity, CG, falls within the safe range for that weight. And, there's even a figure in here, figure 5.1.
Right.
Shows you the kind of data you need for these calculations.
And what I find really fascinating is it's not just about can the aircraft physically take off.
Oh, right.
It's about can it be controlled?
Yeah.
Can it be stable in the air?
Right.
And if that weight is not balanced properly, if it's too far forward or too far back,
Yeah.
it can really mess with how the aircraft handles, particularly during takeoff and landing.
Huge. Yeah, those are like the most critical phases of flight. So, to really understand all this, we need to define some terms.
Okay.
First up, you got the basic empty weight. We call that BEW.
Okay.
And if we look at our example in figure 5.1, that's 1,874 pounds.
Okay.
Now, what that means is that's the weight of the aircraft just as it sits there, including any unusable fuel, all the essential fluids, and all the standard equipment.
Right.
Then you've got the empty weight CG, the
Okay.
EWCG. That's plus 36.1 inches in this example.
Okay.
Now, that tells you where the center of gravity is for that empty aircraft.
Right.
And it's measured from a reference point called the datum.
Yes. And that datum is a really important concept. I mean, think of it like an imaginary starting line.
Okay.
A vertical plane, a line, that is the 0 point
Okay.
for all of those measurements, fore and aft, on the aircraft.
I got it.
And then you have the arm, which is at the horizontal distance,
Yeah.
measured in inches, from that datum to the CG
Okay.
of any item.
So like the seat?
The seat, the fuel tank, your luggage, anything.
Wow. Okay, that makes sense. So what about the moment?
Yes. The moment. The moment is simply the weight of an item multiplied by its arm.
Okay.
So you can think about moment as leverage.
Okay.
So something that's heavy and far from the datum
Yeah.
has a much bigger moment, a much bigger influence on the balance
Then something small and close.
than something light and close.
That's okay.
Yeah,
That's intuitive.
exactly.
Yeah.
It's a measure of that item's tendency to make the aircraft rotate around its CG.
Gotcha. And the CG itself it's like that sweet spot, right?
Yeah, it's that magical point.
If you could suspend the aircraft.
If you could suspend it in midair, that's where it would balance.
Okay. So the handbook also brings up this idea of CG range.
Yes.
Now, it's not just one fixed point.
No.
It's a whole range of acceptable CG locations.
Right.
And what's interesting is this range changes depending on the aircraft's total weight.
Exactly. So for instance, in figure 5.1, at that maximum takeoff weight of 3,100 pounds, the acceptable CG range is from plus 40.9 inches to plus 46.0 inches.
Okay.
But if the weight is lighter, let's say 2,250 pounds or less, that range expands.
Oh.
Goes from plus 33.0 inches to plus 46.0 inches.
So why does that range change with the weight? What's the physical reason behind that?
That's a great question. Because the aerodynamic forces acting on the aircraft change as the weight changes.
Right.
So that optimal balance point also has to shift
To maintain stability.
to maintain stability and control. It's not a one-size-fits-all.
I got it. So the balance shifts depending on how heavy the plane is.
Exactly.
Makes sense. So our example also gives us the maximum weight for takeoff and flight. 3,100 pounds.
Okay.
But it also gives us a slightly lower limit for landing, 2,950 pounds.
Right.
And I guess that difference is to account for the stress of landing.
Right, the structural stresses of landing.
Yeah.
Exactly. And to really visualize all this, you can check out Figure 5.2, which is the airplane loading diagram.
Okay.
And it literally shows you where the key components are
Yeah.
and their moment arms
Relative to the datum.
relative to that datum. So we're looking at front seats,
Okay.
positioned at plus 37 inches, rear seats, further back at plus 74,
Okay.
and then two baggage areas. Area A at plus 97 inches with a max load of 100 pounds.
Okay.
And Area B even further back at plus 116 with a 60-pound limit.
Okay. And the fuel tanks, where are those?
The fuel tanks are at plus 46.6 with a usable capacity of 88 gallons out of 92 total.
Gotcha.
And even the oil has a location. It's specified at negative 15 with a 12-quart capacity.
Interesting. And that negative for the oil means it's forward of the datum.
That's exactly right.
So it seems like every single thing, everything you put on the aircraft has its own specific
Right.
and location
It all contributes.
that all affects that balance.
Yes. And so this begs the question, how do pilots actually determine if their loaded aircraft
Yeah, good question.
falls within these limits?
Mm.
Well, the handbook outlines three main methods.
Okay.
There's the manual computational method.
Okay.
There's the chart method, which uses these weight and moment indexes.
Okay.
And then there's the loading graph method.
Gotcha. So all these are just different ways of making sure the plane's loaded safely before takeoff.
Exactly. Each approach is just designed to achieve that same fundamental goal.
Got it. So let's start with the manual computation method. What's that all about?
So that method really leans on those basic principles of weights, arms, and moments.
Okay.
And the aim is to take the total weight of the loaded aircraft
Yeah.
and its final CG location and relate that to a CG limits chart.
Okay.
Figure 5.3 gives us a good example of a typical worksheet.
Okay.
Essentially what you do is you list everything that you're adding to that basic empty weight.
So fuel, passengers, baggage, all that.
Exactly. Fuel, passengers, baggage, everything, along with their individual weights
Okay.
and their arm lengths. Then comes the big calculation.
Okay.
For each item, you multiply the weight by the arm to determine its moment.
No.
And once you've done that for everything, you add up all the individual weights
Okay.
to get the total loaded weight of the aircraft.
Okay.
And then you sum up all the individual moments to get the total moment.
Okay.
And then finally, to find the loaded CG, you divide the total moment
Uh-huh.
by the total weight.
Okay.
And that'll give you the inches from the datum.
Okay.
And a positive result means the CG is behind the datum.
Okay.
Negative means it's forward.
Got it. So walk us through an example in figure 5.3. You
Yeah.
want to run through those numbers?
Sure. So we have our pilot weighing in at 120 pounds,
Okay.
a front seat passenger at 180,
Okay.
rear seat passenger at 175,
Okay.
88 gallons of fuel, which weighs 528 pounds,
Okay.
baggage in area A at its max, 100 pounds,
Mm-hmm.
and 50 pounds stowed in baggage B.
Okay. So that's a lot to add up.
It is.
What's the final number for the total weight there?
If you crunch all those numbers, you end up with a total weight of 3,027 pounds
3,027.
Yep.
Okay.
and a total moment of 131,806.2 pound-inches.
Wow. That's a big number. Okay.
It is.
So then you do that final calculation, right?
Right. Total moment divided by total weight gives you a CG of
Mhm.
plus 43.54 inches.
Okay. But just having that CG number, that doesn't tell you the whole story.
You're absolutely right. You need to compare that to the acceptable CG range
Okay.
for that specific weight.
Right.
And that's where the CG limits chart, like the one in Fig 5.5, comes in.
Okay.
So you plot your total loaded weight
Uh-huh.
on the vertical axis
Okay.
and your calculated CG on the horizontal.
Right.
And if that point falls within the shaded area, what we call the envelope,
Yeah.
then your aircraft is within those safe limits.
Okay.
So in this example, with a weight of 3,027 and a CG of 43.54,
Yeah.
the aircraft is properly loaded for takeoff.
Okay.
It falls inside that takeoff envelope.
But there's a catch, right?
There is. And this is really important. That same calculation reveals that the aircraft is actually 77 pounds overweight for landing
Oh, wow.
because it exceeds that maximum landing limit of 2,950 pounds.
So it's not just about getting off the ground.
It's not. It's about getting back down safely.
Right.
You got to think about that landing weight. It's non-negotiable for flight safety.
Yeah, that's a huge takeaway. Even for me, I'm learning things here. So even if you're legal for takeoff, you got to consider the landing weight.
Absolutely. This emphasizes how critical it is to consider weight for every phase of flight.
Yeah.
You might be within the limits when you leave,
Yeah.
but as you burn fuel, your weight decreases.
Okay.
But your CG could shift.
Oh, interesting.
So in this case, it's actually the weight, not the CG, that's the problem for landing.
Gotcha.
So a pilot would have to burn off some fuel before landing
Okay.
to get the aircraft below that limit.
Okay, so that makes sense. Now, I know that some people are not going to love doing all that math by hand.
I hear you.
So the handbook talks about the loading graph method.
Yes.
What's that about?
So these charts and graphs, they can be found in the pilot's operating handbook
Okay.
or the aircraft flight manual.
Okay.
And they simplify the process quite a bit.
Okay.
And some of these methods use moment indexes instead of weights and arms directly.
Okay. So the moment index, it sounds like it's making the calculations easier.
It is. It really streamlines things.
Okay.
Multiplying weights and arms can give you these big, cumbersome numbers.
Yeah.
And that increases the chance of making a mistake.
Yeah, totally.
So a moment index is just the moment divided by a reduction factor,
Okay.
usually 100 or 1,000.
Okay.
So you get smaller numbers,
Yeah.
easier to work with.
Less chance for errors.
Exactly. Less chance for errors.
So it's not just about simplifying the math, though, right?
You're right. It's also about visualization.
Okay.
It's easier to see the impact of, say, adding or removing weight in different parts of the aircraft because you're dealing with these smaller, more intuitive numbers on the graph.
Gotcha.
So figure 5.6 shows as a typical loading graph.
Okay.
You'll see these diagonal lines
Mm-hmm.
representing the moment index
Yeah.
for different loading stations.
Like the seats and baggage area.
Exactly, based on the weight.
Okay.
And then figure 5.7 is this loading schedule chart that you use with the graph.
Okay.
So you find the weight of each item on the schedule.
Yeah.
Follow the line on the graph
Yeah.
to find its load moment index.
Okay. I think I get it. So let's walk through that same example
Okay.
using these figures.
All right, so for the pilot and front passenger,
Uh-huh.
combined weight of 300 pounds.
Okay.
You follow the line, you find a moment index of 11.1.
Okay.
Remember, that's the actual moment divided by 1,000.
Right.
Now, for the rear passengers, 175 pounds, the index is 12.9.
Okay.
88 gallons of fuel, 578 pounds, gives you a moment index of 24.6.
Gotcha.
Baggage A, at its 100-pound limit, has an index of 9.7.
Okay.
And baggage B, with 50 pounds, is 5.8.
Okay.
And finally, the airplane's basic empty weight, 1,874 pounds. That has a moment index of 67.7.
Okay. So now we add up all those weights again.
Exactly. You get that total loaded weight of 3,027.
3,027.
Yeah. But instead of calculating the total moment, dividing,
Yeah.
you just add up all those individual moment indexes,
Okay.
which gives you a total of 131.8.
231.8. Okay.
And to see if you're within limits,
Yeah.
use a CG moment envelope like figure 5.8.
Okay.
On this chart, you plot the total weight
Okay.
against the total moment index.
Okay. So same idea as before.
Same idea. If the point falls within the correct envelope, you're good to go.
Okay.
And the handbook says, in this example, it falls within that dashed area.
Okay.
So again, it's properly loaded for takeoff.
Okay.
But it still exceeds that landing weight limit.
So it's still got to burn off that fuel.
Exactly. About 77 pounds of fuel.
Okay.
Yeah.
So whether you're doing it step by step, by hand, with weights and arms,
Right.
or using these simplified charts with moment indexes,
Yep.
it all comes down to the same thing, right?
Sure.
Same goal, making sure the plane is safe to fly.
Exactly. Making sure that before every flight,
Yeah.
the pilot has calculated
Yeah.
and verified
Yeah.
that the aircraft is within its limits.
Both weight and CG.
Exactly. It's not just a box to check.
Right.
This is fundamental to a safe flight.
Yeah, it's really eye-opening to see how these seemingly abstract numbers, weights, arms, moments,
Yeah.
CG,
Right.
they translate directly into real-world safety.
It's a direct connection.
Yeah, a little miscalculation,
Yeah.
a little oversight.
It can have huge consequences.
Yeah, big consequences. So today, we've really delved into aircraft weight and balance.
We have.
We've seen why it's so important
Absolutely.
to stay within those limits.
Yes.
We've defined the key terms,
Right.
like CG, moment, datum, and we've looked at those two main methods pilots use,
Yeah.
the manual and the graphical.
Right.
And it's all about ensuring a safe flight.
It is. And regardless of the method,
Yeah.
the principle is the same.
Right.
Guarantee a safe aircraft.
For takeoff, landing, the whole flight.
Absolutely. Every phase. It's really a testament to those pre-flight checks.
Yeah, that's what makes aviation so safe.
Exactly.
So I want to leave you with a thought. Think about how something as small as where passengers sit,
Yeah.
or how baggage is loaded
Mm.
can have a big effect.
Yeah,
It changes the whole weight imbalance.
it really does.
And it makes you appreciate how interconnected everything is.
In any complex system.
Yeah. So maybe there are parallels in your life
Right.
where that distribution of resources or forces is important for stability, for performance.
It's something to think about
It is something to think about. Until next time.
next time.